So in this problem, we're told to start by drawing a free body diagram. So let's draw the free body diagram on top of the diagram. So we've got a situation like this where we've got a ball hanging from a thread. It ends up making some angle theta with the vertical here, which is what we're trying to find. And then just to the right of it, we've got an additional point charge here. So we know that this ball has a charge of 3 nanocoulombs and this point charge has a charge of 5 nanocoulombs. And what we're going to do is draw the free body diagram for this ball. So let's draw all the forces which are acting on this ball here. Well, it's got mass, so it's got the weight force, which is pulling it downwards. It's also tied with this thread, so it's got a tension force, which is going up parallel to the string like that. And then these two like charges are going to cause a repulsive force between them, so a repulsive electric force. So we've got the Coulomb force, which is going this way. And eventually these all reach equilibrium. So we know that this one plus this one plus this one have to add to give us 0. So this is the tension force and this is the electric force. Okay, now what we're trying to find is theta here. So now that we've drawn our free body diagram, let's once again draw those forces, but if we draw them added head to tail, because we know that they sum up to 0. So here we've got our tension force here, and then going downwards, we've got our weight force, which is our mg, and then our electric force, that's along the line joining these 2 point charges, so that is to the right, so that's this way. So these are at right angles to each other, and the angle between the vertical and the tension is given by theta. So now what we can tell is that the vertical component of the tension force is going to have the same magnitude as the weight force, and the horizontal component of the tension force is going to have the same component as the electric force. So what we can write is that T cos theta has to equal mg, and that T sine theta will have to equal Fe, which is just given by Coulomb's law, which is K Q1 Q2 over R squared. So what we're trying to find is this theta. So let's call this one equation 1, and we can call this one equation 2. And if we do equation 2 over equation 1, then we can write this as T sine theta over T cos theta is equal to K Q1 Q2 over R squared, and then we've got T cos theta on the bottom, so that's mg. And you can see the T's then cancel out. And we know from trigonometry that sine theta over cos theta is equal to tan theta. So we've now got an expression for theta. Tan theta is equal to K Q1 Q2 over R squared mg. And now we can just evaluate this because we know what all these things are. So K, that's Coulomb's constant, 9 times 10 to the 9. Q1, that's the mass, the charge on the ball, which is 3 nanocoulombs. So it was 3.0 times 10 to the minus 9. And then Q2, that's the point charge, which is 5 nanocoulombs. So 5 times 10 to the minus 9. And then R squared, that's the distance between the 2 point charges. So that's 1 centimeter. So we can write that as 0.01 meters, and then we need to square it. And then times the mass, and we were told that the mass of the ball was 2 grams. So that's 2 times 10 to the minus 3 kilograms, and then times G, which we know is 9.8. So solving this on the calculator, we get 0.0689, which we can then solve for theta by taking the inverse tan, and this gives us 3.9 degrees. So that's how we can solve that problem.